name is Nikolay. I'm from Knowles Electronics. We're at Sensors Converge 2024, and today we're talking about V2S vibration sensor. Specifically, we'll focus today on a new application that we are exploring, preventive maintenance. You can look over here at our demo. So, vibration sensor V2S is a one-axis accelerometer with certain key features. Most importantly, high bandwidth up to 10K and above, as well as high SNR, low power consumption, small size, among other benefits. So here we have a demo demonstrating how vibration sensor can be used to detect the condition of machinery for various industrial applications. Specifically, we're demonstrating here electric motors used in the tools, in the drills, and each of them has a bearing inside that spins the output shaft. Here's what it looks like. And inside each motor, we introduced a vibration sensor. And today we have some demonstration software that we can use to compare condition of each motor. Motors are labeled A, B, and C. And inside the motor A has a perfect bearing, which is basically brand new and supposed to give us the best results. But then the motor B and C, we intentionally aged the bearings, and they, you can see they're quite degraded. In the case C, it's completely completely rusty. And so we'll be able to record vibration signature of each bearing of each motor and make conclusions about the health and condition of each tool. All right, so now let's do signal acquisition. So I will start with the first motor with a fresh, brand new bearing. You can see no degradation on it. Turning on some speed. This is a reference tachometer sensor with magnetic sensor under the output spinning part. And 5-second recording starting now. You can see reference sensors giving us about 2,900 RPM. And this is the signature coming recorded on the vibration sensor. Automatic detection from vibration sensors giving us 2892 RPM. Great match. Overall spectrum is showing fundamental frequency as well as multiple harmonics of the main signal. Signal is available up to 20 kilohertz here, really showing excellent wide bandwidth of our vibration sensor. And you can see a resonance at around 7 kilohertz, which is coming naturally from the MEMS element inside V2S sensor. Now I'm going to switch to the next motor B, which is a kind of our medium degraded, partially degraded bearing inside. And again, 5-second recording. You can see that again, we have a fundamental peak, a lot of harmonics, but on top of it, overall noise floor in high frequencies is increasing. And by using wide bandwidth of V2S vibration sensor, we can make a conclusion there is some high frequency random motion going on inside bearing, indicating gradual degradation of this mechanical device. Now, let's switch to motor C, final one with the maximum amount of degradation, maybe a little bit slower. And let's make a recording. In this case, you can see further noise increase across the spectrum, especially focused on high frequencies. There's a lot of random motion. Fundamental peak is present here, but you also start having mid-range harmonics and even a low frequency components. Perhaps it will be easier to analyze the result. Let me turn it off. If we switch to 1/12 octave integrated spectrum, where you can really see the difference in the vibration signature among different bearings recorded with V2S vibration sensor. And this concludes the demo. And again, we were able to use Knowles V2S vibration sensor to compare the health of 3 different bearings, illustrating preventive use case, preventive maintenance of for applications such as engines, pumps, any rotating machines. Thanks for your attention.